Okay, in this revision video we will be looking at inverse functions. First of all, I want to look at an equation. So if x equals 5, y equals 37. Okay, well yes, 7 times 5. If we substitute x as 5 into this equation, 7 times 5 is 35 plus 2 is 37. Yes, I agree with that. Okay, if y equals 30, what is the input value x? If I substitute y as 30, what I could do is take 2 off both sides and divide both sides by 7, which gives us x is 4. Now, let me take the equation y equals 7x plus 2. You can almost think of x as the input and y as the output. We know the output, we want to work out the input. I'm just going to make x a subject here by taking 2 off both sides, dividing both sides by 7. So here, the output was 30. I put the output into this equation here. 30 minus 2 is 28, divided by 7 is 4. So this is almost like an inverse function. It's like you know the output and you're working out the input. How do we do that in function notation? Well, as we've seen in an earlier video on the functions topic, in function notation we would write this as f of x equals 7x plus 2. So the inverse function is used to put out if you have the output, if you have the answer, and to work out the input. So you've just got to follow some steps to find the inverse function. And the notation for inverse function is f to the minus 1x. So your step 1 is put equal to y. Put the function equal to y. Step 2, make x a subject. How do I make x a subject? I take 7x off both sides. No, I don't. I take 2 off both sides. And I divide both sides by 7. And the step 3, I write in function notation. Which is putting the function in terms of x only. So in here, I replace the y with an x. So, just using this first example, we know the output is 30, but you would be told in a function notation question, f to the minus 1x is equal to 30. Find the value of x. 30 minus 2 is 28, divided by 7 is 4. Okay, if you want to have a go at these yourself first, by all means put me on pause. If not, you might want to watch me demonstrate the first few and have a go at the rest. Okay, so for this first one, put it equal to y. Make x the subject by dividing both sides by 2, and then write in function notation by replacing the y with an x. B. Put equal to y. Make x the subject, and write in function notation. Okay, E. And F. Okay, question 2. Part A, part B. Oops, sorry, it should be h to the minus 1, apologies. And so h to the minus 1 of 1.5, 4 times 1.5, 6. I want to just practice a few more of these. You can have a go at these questions too. Sometimes the function notation is slightly different. I think we did discuss this in the first recording. You might be given the function notation in this form. It is just the same idea though. I suppose if you wanted to keep to the same notation here, f to the minus 1, taking 12 from both sides, divided both sides by minus 5. Just going to expand the brackets when I put it equal to y. Question 5. Divide both sides by 3y. I'm going to add 3 over x to both sides first. You might do that a slightly different way from me. And then I'm going to subtract y off both sides. Take it to the top here, times both sides by x. Expand your brackets. No, I'm not, because I want to make x a subject. So I'm going to divide both sides by 4 minus y. And then write in function notation. Wait, which question is it? 7. So it would be p to the minus 1. Just notice 6 should be g to the minus 1. Question 8. Square root both sides. Don't forget you have the positive and negative square root. I have copied the question down wrong here. That should be a minus 5 there. So plus 5, plus 5. So now we have the inverse function. F to the minus 1 of 3. 8 over 2, which is 4. F to the minus 1 of 0. 0 plus 5 over 2 is 2.5. F to the minus 1 of negative 3. 1. And question 10. Solve the equation f of x equals f to the minus 1 of x. I'm going to times both sides by 2. I'm going to multiply out the brackets. Subtract x from both sides. Minus 10 from both sides. Divide both sides by 3. Here we will look at a more advanced question of finding the inverse function. We start out as normal. Put the equation equal to y. Put the function equal to y. make x the subject by timesing both sides by 4 minus x. Expand the brackets. We need to make x a subject. So anything with an x we're going to take to one side of the equation, anything else on the other side. So I am going to bring anything with an x on the right hand side. I'm going to add xy to both sides first. And on the right hand side we have a 3, which we want on the other side of the equation. So I'm going to take 3 from both sides. So at this point, how do we isolate the x? So it's a higher level skill now, remembering how to do these. We have done this before when you've been changing the subject of formulae more advanced. So well done if you remembered. You factorise it by taking out an x. Just in a single bracket. Now we can make x a subject by dividing both sides by 2 plus y. And now I need to write it in function form, function notation. Okay, have a go at these 5 questions. Again, put me on pause, unpause when completed. Okay, let's start with this first one. Make x subject by timesing both sides by x. Bring everything with an x on one side. I'm going to take x off both sides. Factorise into a single bracket. Make x a subject. And then I'm going to write in function notation form. Now, there is another answer for this because some people may have taken the x's to the other side. If you had have done that, you would have got the answer that either of those are correct. Next question. Question 2. Times both sides by x minus 1. Expand your brackets. I'm going to bring the 2x over to the left by taking 2x off both sides. And I'm going to add the y to both sides. Factorise. Divide both sides by y minus 2. Write in function notation. Or if you'd have done it the other way, you would have got minus x over 2 minus x. Question 3. Times both sides by 2x minus 5. I'm going to minus x from both sides and add 5y to both sides. Divide both sides by 2y minus 1. Or you might have had either are correct. Question 4. Minus x from both sides and minus y from both sides. Divide both sides by 3y minus 1. Or the alternative question number 5. Find the inverse function. Let's put it equal to y. We just change up this colour. We need to make x a subject, so we're going to multiply both sides by y. Then we're going to expand the brackets. Then we're going to bring anything with an x on one side. So we're going to take 2x off both sides, and then we're going to add 4y to both sides. I'm going to factorise. And then I'm going to divide both sides by y minus 2. So x is equal to minus 3 plus 4y over y minus 2. I am now just going to write in function notation and replace the y's with x's. The alternative to this answer is 3 minus 4x over minus x plus 2. Okay, question number 5. Okay, finding the inverse of a quadratic function. So there's something else you've got to be aware of here. This is higher level again, finding the inverse of a quadratic function. I would suggest you watch a recording on completing the square if you can't fully remember that topic, because you will need that skill for these questions. So when you find yourself in the position of having a quadratic function, let's just start out as normal. Let's put it equal to y. Now, if we try to make x subject here, it wouldn't work. Because we take the 2 over, we try and put the x squared plus 4x in brackets, and you'd have x bracket x plus 4. Let me just show you. This is incorrect. And we'd have... But if you put that in a bracket, if we divided both sides by x plus 4, we still have x on both sides. So we need a different method. And the method you need to remember when you have a quadratic is to complete the square. solve by completing the square, or make x a subject by completing the square. Halve our 4. 2 times 2 is 4, so we need to take 4 off. We now need to add 6 to both sides. Square root both sides. Remembering you can have a positive or negative square root. And now minus 2 from both sides. And find the inverse function. Okay, have a go at these 3 questions. Put me on pause and pause when you're done. Half of 2 is 1. Add 7 to both sides. Oops, excuse me. Noticed a mistake. My brain, I think, just worked that out. The reason I'm taking off 1, because it's negative 1 times negative 1 is positive 1. We do not need that. Right, add 6 to both sides. Square root both sides. Add 1 to both sides. And then let us write in function notation. Part B. Half of 8 is 4. Add 38 to both sides. Square root both sides. Add 4 to both sides. Write in function notation. Part C. Minus 15 times minus 15 is positive 225. Add 325 to both sides. Square root. Add 15. And write in function notation. Then lastly, we're going to be looking at finding the inverse function when you have a quadratic and the coefficient of x squared is greater than 1. So this is probably grade 9, I would say. Okay, I'll do this first one as an example. Maybe look at the other two yourself and put me on pause. So start out with normal. Put the function equal to y. It's a quadratic function, so we are going to complete the square, but it's a little bit more difficult completing the square when your coefficient of x squared is greater than 1. I'm going to put it in a factorise it by taking 3 out of the first two terms. I'm just going to leave this 3 on the end. You could put it all in a bracket, I guess, but I just prefer to work with the first two terms. You'll see why in a minute. So now we have a coefficient of x squared, which is 1, so we can now complete the square. Half this term 4. 2 times 2 is 4, so we need to take 4 off. Right, now we need to expand the big brackets. This times is minus 4 by 3. And we've got that plus 3 at the end. Just going to continue up here. And minus 12 plus 3 is negative 9. Now we're going to add 9 to both sides. I'm going to divide by 3. Square root. Take 2 off both sides. And then finally replace any y's with x's and write in function notation. Okay, so maybe have a go at 2 and 3 yourself. Put me on pause and pause when you're done. Complete the square. No, factorise. You can check it at this stage. Well, if I expanded these brackets here, I'd have 2x squared plus 16x minus 20, which is what we have in the first line. Now I can complete the square. Half of 8 is 4. 4 times 4 is 16. Simplify by expanding your big brackets. Simplify. Divide by 2. Minus 4. No, square root. Minus 4. Writing function notation. Last question. Complete the square. Half of 2 is 1. Minus 1 times minus 1 is 1. So I need to take off 1. Expand my big brackets. 3 times minus 1. Minus 3 plus 1. Take 1 off both sides. No, add 1 to both sides. And then let's write in function notation. There should be one more recording to watch on this series of functions, so which is the domain and range of a function.